All right, let's go ahead and do rate problems video number 2 here. It's number 1, so it's a calculator active question. It says fish enter a lake at a rate modeled by the function e, given by e of t equals 20 plus 15 sine of pi t over 6. Fish leave the lake at a rate modeled by function L, given by L of t equals 4 plus 2 to the 0.1 t squared. Both E of t and L of t are measured in fish per hour. Again, sounds like a rate. And t is measured in hours since midnight at t equals 0. So the first reading through this, I see two different functions, E of t and L of t, where E of t is a rate that models how fish enter the lake, and L of t is a rate of fish leaving the lake. So we have a rate in, E, and a rate out, L. So I'm going to draw a lake, and we're going to have fish enter the lake as E of t, and we're going to have fish leave the lake as L of t. And both are measured in fish per hour. So it's fish per hour. Now, one difference about this, the fish entering the lake problem, or the lake problem, as opposed to the one that we did yesterday, is I don't have an initial value here. I wasn't given the total number of fish that started in the lake at t equals 0. Okay, so I only have entering E of t and leaving L of t. All right, let's go ahead and read letter A. A says how many fish enter the lake over the 5-hour period from midnight, t equals 0, to 5 a.m., t equals 5. Give your answer to the nearest whole number. So if I just want fish entering the lake, I want E of t. And if I'm doing that from 0 to 5, I'm probably going to need to have an answer that takes into account an interval of time. Now, let's look at what we've got here. E of t is a rate, right? And I want total number of fish, going from a rate level to an original function level, which means that I'm going to set up an integral. Now, my integral is going to go from t equals 0 to t equals 5. So from 0 to 5. And I'm only interested in the fish that enter the lake. I'm not concerned about fish leaving the lake, only fish that enter. So I'm only going E of t dt. Now, it's a number 1, so it's a calculator active question. So this is your opportunity to go ahead and plug this function into your calculator as an integral from 0 to 5. I think I've already done this. Yeah, and I think you end up with about 153.4576. Now, they did ask us to give the answer to the nearest whole number. So I think that would mean 153 fish. And we're only talking about entering, so enter the lake from midnight, t equals 0, to 5 a.m., t equals 5. All right, let's go ahead and drop down to letter B. B says, at what time t, for the interval from 0 to 8, is the greatest number of fish in the lake, and justify your answer. That greatest sure sounds an awful lot like a maximum value, and in this case, an absolute maximum value. So we want to know about the greatest number of fish in the lake, which means if I go back up to my picture up here, if I want the greatest number of fish in the lake, I need to consider both fish entering the lake and fish that are leaving the lake. So I have to somehow combine E of t and L of t. Well, E of t is fish entering the lake. That means I'm accumulating fish. That means that to start with, I am going to accumulate fish by E of t. L of t is fish leaving the lake, which means that now I'm losing fish, which means that I want to take L of t, and I want to go ahead and subtract it because this is my negative rate. Now, E of t minus L of t is going to represent the rate that fish leave and the rate that fish enter and the rate that fish leave. Now, if I'm trying to find a maximum or greatest value, I need to take into account a couple of different things. The first is critical values, which is when the first derivative is 0. Now, E of t minus L of t, these are both rate equations, so to find the critical values, I want to know where E of t minus L of t is 0. Now, this is, again, an opportunity for you to get into your calculator and do E of t minus L of t and set that equal to 0. And I think that when you do that, you're going to find that the t-value that you come up with is 6.2035. So the critical value, or the time at which we would have a critical value our fish here, is at 6.2035. Now, that's just one of the two things that we need to take into account when we're thinking greatest number of fish. The other thing that we need to take into account is the endpoints of the time interval that we're looking for. So we've spent a lot of time doing these types of problems and organizing our thoughts in a table. So I'm going to go ahead and set up my table. Now, some people will make up a function and say, I don't know, like A of t or B of t will equal this, and they'll do that. I think it's just fine to put E of t minus L of t over here as our output. The inputs that we're going to take a look at here are 0, 6.2035, and then 8 is our other endpoint. Now, I want to be able to go ahead and find out what the total number or the greatest number of fish is going to be, which means that I need to go back to an original function level. Now, my equations that I'm given for E of t and L of t, those two ugly looking functions up above, those are rate equations, which means that if I'm trying to go from a rate equation to an original function level, that means I want to go ahead and integrate my function. So I want to integrate from a value that we know. And the value that we know is starting at t equals 0. So I'm going to write an integral function here. Let's go ahead and write it over here first. I'm going to start from 0, and I'm going to go to some value. We're going to go to a lot of values, right? We're going to go to 0. We're going to go to 6.2035, and we're going to go to 8. And what we're going to be integrating is E of t minus L of t dt. And in fact, actually, I should probably put my t up here, right? Because our input is t. And I should use my dummy variable here. So let's go with E of x and L of x dx. Let's do that way. So to find the outputs of this, I'm taking my rate equations and I'm integrating them and getting them back to the original function level. So I'm going to go from 0 to 0 of E of t minus L of t dt. And no calculator needed. The integral from 0 to 0 is going to be 0. For 6.235, we're going to go integral from 0 to 6.2035 of E of t minus L of t. And again, I've already gone ahead and done the calculations here. I think it's 135.0142. All right, and then the last one, I guess I'll just put this down over here. Integral from 0 to 8 of E of t minus L of t. And this one is, I think, equal to 80.9199. And we wanted the greatest number of fish. I think that happens here. So our max fish is probably 135 fish at t equals 6.2035. All right, let's go ahead and jump down to C. Last one for this one. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? T equals 5. So for this one, we want to see if the number of fish in the lake is increasing or decreasing. Number of fish increasing or decreasing should be taking a look at the first derivative level. Okay? But for this one, I need to take into account not just fish entering the lake, but also fish leaving the lake. So I want the first derivative level. So I want E of t, and that's a rate, first derivative level, right? We're good. And I'm going to go back to the minus L of t, right? Because that is fish that are leaving my lake. And for this one, I want this at a very specific moment in time. I want t equals 5. So I'm going to go E of 5 and minus L of 5. I want the fish entering the lake at this specific moment in time minus the fish leaving the lake at this specific moment in time. And again, another calculator is valuable sort of question. If you take E or 5 and plug it in for both E and then subtract it from L, or 5 plugged into L, I think you'll end up with negative 10.7228. So that means that the L, the fish leaving, is going to be bigger. This number has to be bigger than that number. We ended up with a negative thing, so we can say because E of 5 minus L of 5 is less than 0, right? It's negative. It's a negative rate. The number of fish is decreasing. And then let's go ahead and center it at t equals 5. It asks for a specific moment, so let's go ahead and mention the time. All right, look this one over. See if you have any questions. Please make sure if you do have questions, to reach out and let me know. I'd love to answer them for you.